Dear students, in today's class we are going to see an example of a integral domain, and if you understand this example you can solve example of similar type. So in today's class we are going to show that z of under root of 5 is an integral domain, but the question is what exactly integral domain is. So integral domain is a commutative ring with unity without zero divisors. But in the question it is already given that it is a ring, and we also know it, right? So the only question remains whether the ring is commutative with unity and the condition of without zero divisors. So first of all we will try to show that the ring is commutative. And what is the condition of commutative ring? Given a ring R, given two elements of the ring A and B, it is said to be commutative if AB is actually equal to what? BA. So in order to prove this ring is commutative, we are supposed to take two elements of this ring. The first element we will call it as A plus B under root of 5, and the second one as C plus D under root of 5. So let A plus B under root of 5 and C plus D under root of 5 belonging to Z of under root of 5 be any elements. Now we have to show that the multiplication is commutative in the sense A plus B under root of 5 multiplied by C plus D under root of 5 is exactly equal to C plus D under root of 5 multiplied by A plus B under root of 5. So we can do this in two ways. Either you can start with LHS and prove directly equal to RHS, or you can do separate calculations for LHS and RHS, and you can ultimately show both sides are same. So first of all, consider A plus B under root of 5 multiplied by C plus D under root of 5, and let us see what we get. And similarly we will do the calculations for C plus D under root of 5 and multiplied by A plus B under root of 5, and let us see what we get. So first of all we have to multiply these terms together by the usual properties of multiplication that we know. So this will be equal to AC plus 5 BD. Remember it is root 5. So root 5 multiplied by root 5 will be 5 plus AD plus BC outside the bracket under root of 5. Now similar calculations for this multiplication as well. So it will be CA now, right? CA plus multiplication of these two, that is 5 dB plus this will be CB plus DA under root of 5. Now by first observation you will notice that this doesn't look to be equal, right? But actually it is, and there is a reason for it. So if you see, it is AC plus 5 BD, but here it is CA plus 5 dB. But the question is कि ABCD are nothing but what? They are integers, and we already know that the set of integers is a ring, right? In fact a commutative ring. Thus we can do the adjustment. This 5 dB is same as 5 BD, and this CA is actually same as AC. So I will write it as AC plus 5 BD plus the same reason works here as well, and this is same as AD plus BC under root of 5. So what I have used here, since Z is a commutative ring, and you can see that you can call it as sum 1, call it as sum 2. So from 1 and 2 what do we have? this a plus b root 5 multiplied by c plus d root 5 is actually equal to c plus d root 5 multiplied by a plus b root 5, and therefore z of root 5 is a commutative ring. Now the question is, what about unity? Generally, whenever we think about unity, we think about 1, right? So the question is, will 1 work here? So if you see the multiplication of a plus b root 5 multiplied by 1, the usual one of integers, so this is actually equal to what after simplifying? One can observe that this is 1a plus b under root of 5 itself. Thus, that 1 acts as an identity element in z of under root of 5. So what I will say here, 1 belongs to z of under root of 5 such that this happens for all a plus b under root of 5 belonging to z of under root of 5, and therefore what we have shown, z of under root of 5 is a commutative ring with unity. Now it remains to show that it is without zero divisors. So you can take a screenshot probably and we'll meet again. Now we will show that our ring z of under root of 5 is without zero divisors. So in order to show it, we will need two elements of the ring such that the multiplication is equal to 0. Remember, what is the condition of without zero divisors? A ring R is said to be without zero divisors for any two elements a and b of the ring R. AB is equal to 0 implies a is equal to 0 or b is equal to 0, or there is one more, the contrapositive. For AB belongs to R, which are both non-zero, implies AB is non-zero. But here we are going to use the first one. So what I have taken, I have already taken two elements of z of under root of 5, a plus b root 5, c plus d root 5 belonging to z of root 5 such that their multiplication is actually equal to 0. Then I have multiplied this equation, this one, by a minus b root 5 and c minus d root 5, and I have adjusted their positions according to my requirement. I have written a minus b root 5 here and c minus d root 5 here. Remember, why I can do it? Because we have already shown that z of under root of minus 5 is a commutative ring, right? Since it is commutative, so we can adjust the positions of the elements as per our requirement, right? Now, what it will imply, we already know the formula, a plus b multiplied by a minus b is a square minus b square. That formula can be used. So a square minus 5b square multiplied by c square minus 5d square will be actually equal to 0. But note that all these a, b, c, d are integers. Therefore, this a square minus 5b square will be also integer, as 5 is an integer. Similarly, c square minus 5d square, it is also going to be an integer. So actually what we have, the multiplication of two integers is actually equal to 0. But what do we know? We know that z is an integral domain. So we have multiplication of two integers equal to 0. So what it will imply? A square minus 5b square is equal to 0, or c square minus 5d square is equal to 0. So the question is, for which values of a and b this a square minus 5b square will be equal to 0? If you try to solve it a bit, you will observe that a square, this a square minus 5b square is equal to 0 will imply a square is equal to 5b square. So, for which values of a and b LHS will be equal to RHS? That is 0, right? A should be 0 as well as b should be 0, then and then it is possible. So, I will say this will imply a and b both should be 0 and on this side c and d both should be 0, but a and b is equal to 0 will imply what? This a plus b root 5 is actually equal to 0 and this c equal to 0 and d equal to 0 will imply c plus d root 5 is equal to 0. So, what we have shown? So, we have shown this z of under root of 5 is without 0 divisors. So, initially we have shown that this ring is a commutative ring with unity. Now, we have shown that it is without 0 divisors and therefore, it is an integral domain.